Hey, Marcus House with you here. Today we are sending a vessel up to the moon. This is going to be a reusable moon transfer vehicle. We're sending this today, of course, with the Falcon Heavy. And as we launch from the launch pad, we'll just talk a little about the Falcon Heavy and the reason why we're using it in this launch. The main reason being because the payload mass of this transfer vehicle is quite large. And we do need to get it to quite a high orbit in order to have enough fuel to get to the moon in our first trip. But there's going to be multiple launches in this video because we not only need to get this vessel up ready to go, we also need to send the crew up, which we're going to be simulating with a Falcon 9 here shortly. So lots to happen. We have the thrust of the core limited right down, so the fuel in that central booster is going to last a lot longer than the two side boosters, just like what we saw in the real Falcon Heavy launch many months ago now. Now the idea with this moon transfer vehicle is that we will refuel it on the moon, and if you want to check out the video that we did before this, we actually sent a refueling vessel which was going to permanently stay stationed on the moon. Just luckily the payload mass for this vessel is just a little lighter, so we're going to be attempting recovery on all three of the boosters today. We have of course just seen those two boosters fall off there. They've got enough fuel remaining to do a double drone ship landing out in the ocean. Like I say, the payload mass is smaller than in the last vessel from the previous video. In that video, of course, we expended the central core completely. We just didn't have enough fuel to make the mission. In this mission, we are going to attempt to recover it. So decoupling there now, we have enough fuel left in that core booster, hopefully to come down and land. And there go the fairings as well, exposing our moon transfer vehicle. Now the second stage here has got the one single Merlin vacuum engine. Now that vacuum engine is super efficient, but it does have quite a low thrust, so it's got a lot of work to do. Meanwhile, our two side boosters from the Falcon Heavy are coming down over the top of the drone ships. We can just slightly see there in grey at the bottom of the screen, there they are. I've got these programmed to bring themselves down over the top of the drone ship using those grid fins, but as we get closer it looks like we're going to overshoot a little bit. We need to move back this way, come on! And oh god, the other one's way off course. It's landed in the ocean. This one's just touched down on the drone ship, and yes, a little seawater damage, some corrosion to deal with. Sorry Elon, that must have been a bug, mate. I will try to get right on that. Our stage 2 here still limping its way to orbit over 5,500 meters per second as our core booster starts coming very quickly down into the atmosphere. This is going to be a very hot run. We need to really utilize those grid fins to wipe off as much velocity as possible because we've got basically no fuel in this left. A quick burst at the end, and looks like this one's better. Looks like my scripts are succeeding this time, right in the center of the drone ship. Wonderful landing. And our stage 2 is just coming up to orbital velocity, which is just shy of 8,000 meters per second. Few more seconds to burn here, and we still have a little fuel left as we reach orbit. We're going to need this fuel because we are going to be boosting our apoapsis up to around 1,500 kilometers. Currently our apoapsis is at 250 kilometers. We're boosting that up to around 1,500. Very small burn. Doesn't take long to get there. 1, 2, 3, 4, and 1,500 just. We'll just use a little RCS thrust just to perfect that, so we're just at 1,500. We're then going to pull out those solar panels, make sure that our batteries are charging correctly before we put our reusable moon transfer vehicle into its resting orbit, awaiting the crew. So we're just time warping now until we get to the maximum height in our orbit. Of course, that's the apoapsis. And as we head towards the apoapsis, we just need to again turn prograde. So we'll turn the vessel prograde and get ready to do our burn. Now, of course, in real life, there is no way that anybody would waste this much fuel turning a vessel this quickly. You would just do a very small push and you'd rotate your vessel over a number of minutes, so you're not wasting too much. This burn here will only last for a few seconds, just until we can raise the periapsis there right up to the same altitude as our apoapsis. We'll decouple the vessel, and we've now just got around a couple of... You see only there 300 units of kerosene in the stage 2, but because there is no mass attached to this thing, this will go a very long way. We're going to do a very quick deorbit burn, and you'll see just how much velocity is wiped off. And that's it. That is the whole burn, and this is going to now easily fall back into the atmosphere. So it's amazing just how much thrust that vacuum engine has when there's no payload attached to it. So our stage 2 is now plummeting back into the atmosphere. Our periapsis is actually very low. We actually did our burn to drop it right down into the negatives. So this basically means that it is just going to hammer down through the atmosphere at quite a high angle. The only thing here surviving being the single Merlin vacuum engine. Of course, in real life, we quite often find remnants of old engines that have crashed back through the atmosphere, and in a lot of cases they're quite intact considering the punishment that the re-entry here puts them through. And there we go, we have the splashdown there. So here we have our moon transfer vehicle silently orbiting around the planet, just awaiting a crew to take it on its very first trip to the moon. The vessel here is already fully fueled with liquid hydrogen and liquid oxygen, and that weighs in at around 40 tons. So we need to prepare our crew. We have a little bit of a makeshift capsule here because we don't have a very good replica of the Dragon, but we have our two pilots, Valentina and Burberry Kerman. They're going to pop up here into the vessel and they're going to be heading to the moon today. But first, we need to launch this thing at the right time because we need to make sure that our inclination is correct to match both our moon transfer vehicle and of course the moon itself. So we initially launched the moon transfer vehicle on the exact same inclination to make sure that everything matches up nicely. Launching the Falcon 9 there, beautiful plume coming out the bottom of the launch tower there. Valentina and Burberry Kerman in the bottom right there, looking very excited to be the first Kerbals to land on the moon in well over 45 years. So we're just heading up to around 800 meters per second here, surface speed. This vessel is only very light because of the one capsule at the top, so we have got more than enough fuel to do a return landing to the launch pad. So we're going to do a boost back burn immediately after cutoff here. So there goes our stage 1 booster separation there. So yes, because we didn't have any fairings, all that weight is actually never needed as well, so that makes this payload just a little lighter also. Our first stage doing its boost back burn to bring it into a trajectory to come right down over the top of the KSC. Meanwhile, our second stage here coming up to around 2,600 meters per second. Velocity is going to increase very quickly here soon as a lot of the fuel empties out. Meanwhile, we can head back to our booster stage, which is re-entering the atmosphere now. Because the horizontal velocity of this vessel isn't very high, only a tiny little re-entry burn before we let the grid fins completely take off the vast majority of our velocity. It does look at this point like we're going to overshoot it, but the grid fins are very good at redirecting the vessel back over the top of the launch pad. We have our 3-engine burn, switching to the single engine to touchdown, and there we go, right in the center of the pad. So our second stage burn here is just passing 7,000 meters per second, almost at orbital velocity. And there we go, engine cut off there. Our apoapsis is currently sitting around 630 kilometers. Our first stage doesn't have enough fuel to make it back if we were to boost any higher, so we've decoupled that there quite rapidly actually. It was a very forceful decoupling. A very, very small burn here just to drop this second stage back into the atmosphere. We're not going to watch this one, we've already seen one of those re-enter today, so we can rest assured that our stage 2 is going to head off there back into the atmosphere. Just manually extend these solar panels just because I forgot to put an action group on them. You can see that our vessel here has a slight tank on the back, and on that we have just a few tiny little Super Draco thrusters. Now that has given us enough delta V in this vessel to do a number of small corrections, intercept with our moon transfer vehicle, which I'm just setting up here now. So we're going to do a very small 268 meter per second burn just to get our intercept organized. And there we go, very small burn there. And burn complete. So we'll just time warp around now to meet up with our moon transfer vehicle. Just before getting to that point, we'll turn to the retrograde mode for target on our navball because we have the moon transfer vehicle set as our target. And after just a few small corrections, we are now on a quick intercept to head straight to that target. As we approach that, we can just do slight adjustments coming in to make sure that we're approaching dead on. That way we're not wasting too much fuel burning back and forth. Now, what you'll notice here as I'm coming into dock with this vessel is that we still have almost half of the fuel remaining in this capsule stage. Just also decoupled that top little nose cone, and what I wanted to do actually is find a nose cone that retracted. Whoops. I just wanted to find a nose cone initially that just opened up and closed, but I couldn't actually find one. So if you imagine that the nose cone would open and close like the Dragon is supposed to, then that would be fantastic. So just coming in here to dock now, we're just going to come in very, very slowly, and make sure you turn SAS and the reaction controls off, otherwise it gets a little hard to dock properly. So our two Kerbals are going to transfer over into our moon transfer vehicle. You'll see that the capsule on the moon transfer vehicle is actually very small. I couldn't find a newer one with the correct mass, but there's been proposals of capsules that don't need all the shielding and re-entry considerations that would be required on a vessel that's going to come back through the atmosphere. So this is a real bare bones light vessel that is just only supposed to ever work in a vacuum. We have Burberry here scanning around the bottom of the vessel, making sure all those engines are looking fine for the next firing. Those three engines down there are the RL10 engines, all three of them, and in this configuration we're using a prototype version of that, which is the CECE engine. So now that our Kerbonauts are aboard, we can now decouple from that stage. We're going to leave that stage there in orbit. It still has enough fuel to come and redock and then send our Kerbals back to re-enter in the Earth's atmosphere and land. So yes, it's going to be a very efficient mission. We're just going to set up our maneuver node here to make sure that we do a very efficient burn out and meet up with the moon at the exact inclination, or very, very close to. You can see that our relative inclination right now to the moon up in the top left-hand corner there is 0.006 of a degree, even less than that as we are actually doing this burn here now. So very, very accurate. We have those three CEC engines there firing, and this engine in particular has got the ability to thrust right down to around 8%, which is just amazing. We talked a lot about this in the previous video as well. We have our two Kerbonaut pilots sitting there patiently waiting for this burn to complete. They also had a corned beef sandwich sitting there in the pilot's seat as well. That's obviously a reference there to John Young, who sadly died this January 2018. Just finalising our burn there to the moon, bringing our periapsis there around the moon right down to around 100 kilometres. And as we let the Earth there slowly fall away from us, we can again be inspired by those words from Carl Sagan. That's here, that's home, that's us. On it, everyone you have ever heard of, every human being who has ever lived out their lives. We need to appreciate that pale blue dot. So our Kerbals are certainly appreciating it. They are bringing this vessel down here into a low moon orbit. They need to do a retrograde burn here. This burn is only around 700 meters per second. We have quite a lot of fuel remaining, more than enough to actually touch down comfortably on the moon at this point. You'll see what we've done here is actually turn the central engine off. That is because we don't need a huge amount of thrust at this point, and we can save our central engine just for touching down and doing smaller maneuvers, because that's what we're going to be touching down with. So we want to save as many of the engine ignitions as we can, within reason. We don't have to be too picky, because these engines are made to fire quite a large number of times, around 50 in the game simulation here. So yeah, we don't need to worry too much. We'll be able to use this vessel many times over to do all of these upcoming future missions. So again, just doing our next burn here just to bring our trajectory right down over our landing site. Our landing site, of course, is where our refueling station is waiting for us, fully fueled. And this is actually the most difficult part of this mission, because we need to make sure that as we come down over the vessel, we actually land right down next to it, because our Kerbals need to hook up a refueling cable between the two vessels. So we're actually firing all three engines now, and what we're going to do as we come up over the top of the vessel is just turn off the outside two engines, leaving us with the one single engine limited with its thrust right down, so that we can come and touch down nice and gently and control our descent to bring ourselves right down over the vessel. Pop out those landing legs there, we'll bring in the solar panels, we don't need to risk those at the moment. Now you'll see here as I bring the vessel right down to touch the surface of the moon that I'm trying to get the anti-target marker to line up almost exactly with the retrograde marker. This took a little bit of practice. I had a number of failed attempts trying to manually do this, but you can see I kind of got the hang of it and brought the vessel right down very, very close. I did a few little hover hops just to get just a little bit closer after this as well. You can see me sort of tinkering there with the position of the vessel. So we now have our Kerbals on the surface of the moon with our reusable moon transfer vehicle. Burberry descending first. We'll just pop out that ladder there quickly before he falls off it and pop down on the moon's surface. So there we go. We have our first Kerbal on the surface of the moon for more than 45 years. And we just need to jump up here. This probably could have been redesigned a little better. I'll just link that there. We're going to take our refueling cable over to our full refueling vessel here, and I haven't got this angled very very well at all. I'll pop it up here on this, link that, and of course the pipe is going straight through the drill. Anything works in Kerbal Space Program. This is a victory for Burberry. Anyway, he's going to hover out here. We're going to get our nice, probably a thumbnail shot. We'll see. We'll pop out our flag. There we go. And yes, head back here. We'll get our other Kerbal out as we're transferring some fuel. So we'll get the fuel transferring from our refuel rig over into our reusable moon transfer vehicle. And there we go. We can pop Valentina out, and she can come and join Burberry for a celebration here on the moon's surface. As much of a celebration as you can have with spacesuits on. So now that our refueling is complete, we can go and unlink those. We'll just see if we can jump Burberry. No, not quite. It's okay. We'll head over here. We'll unplug our link there, our refueling pipe. And we're all ready to basically go and perform another mission. Now, with our vessel fully fueled here, we can easily launch from the moon's surface and get all the way back to a low Earth orbit to meet up with our return capsule. No problem at all. We actually have fuel to spare. So we'll pop out the solar panels, make sure that we've got a full charge, and we just need to make sure that we pick the correct time to launch. And we need to make sure that we head out in the same direction, the same inclination that the moon is orbiting around the Earth. So we've got that about right here now. What we need to do is make sure that we can turn our trajectory here to around 63 degrees on the nav ball, the heading there on the nav ball in the bottom. Of course, the heading will change depending on when you do your launch from the moon. It's actually a little tricky to figure that out. Now, it doesn't take long to get into a moon orbit. The orbital velocity is only around 1600 meters per second. Now, if you compare that to the Earth is almost 8,000, so a huge difference there. And it's going to actually take us a lot more delta V to get down into a low Earth orbit. Just to maximize efficiency, we did take off with all three engines. That just means that we've got the maximum thruster weight available, and we're not going to lose a lot of efficiency due to gravity losses, so that is good news there. Now, the main reason that we really want to reuse this vessel multiple times to do trips to the moon and back to low Earth orbit is because the components of this vessel are going to be very expensive. Just the engines alone make up a huge cost of this vessel. These RL-10 engines have in the past been sold for somewhere between $15 million and $20 million, depending on when they were purchased and in what configuration they were purchased. And of course, there's 3 of these on this vessel, so it makes a very expensive vessel to just throw away into the atmosphere and never reuse in a second mission. And because these engines are fueled with liquid oxygen and liquid hydrogen, and because they can actually burn quite cool on the outside, they can actually be used many, many times over. The CECE version of the engine has had some very exciting tests done way back in 2009, where NASA was reporting that they were able to throttle the engine right down from 104% thrust right down to 8% thrust, which is an absolute record as far as I've ever seen for an engine of this type, fueled by liquid oxygen and liquid hydrogen. Now, the RL-10 engine has been used for a very, very long time. In fact, the first flight occurred in 1961, so that just goes to show just how reliable these engines are. And they've been used for such a long time now that there's been so many versions of them made. In fact, just in 2018, just this year, Orbital ATK announced that it was going to be using 2 RL-10C-5-1 engines for the Omega A to power the upper stage. So very exciting stuff coming up there. And also in May this year, ULA announced that they would be be using the RL-10C-X for the upper stage engine for the next generation of the Vulcan Centaur rocket. So we've just seen the very first retrograde burn to bring ourselves into a lower orbit around the Earth after returning there from the Moon. A slight correction here with the RCS so that we can get our intercept organised, and we'll just come around to do our second burn here, flip around a retrograde again. In this burn we'll be able to organise our intercept at the same time. You'll see the pink intercept marker moving around. We just need to burn until that meets up with the intercept marker right down here. We'll just lower the thrust right down, zoom in, and just get that as close as possible. There we go there. So one more orbit around and we're going to be right on top of our vessel. Basically, you can see them both coming around here. Our relative velocities aren't that different, so as we get close to the intercept, we just need to turn our vessel retrograde towards the target, wipe off all of that relative velocity, and we'll just keep approaching at around 6.5 meters per second. As we do so, we're going to use our RCS to push the anti-target and the retrograde markers together. That means we're going to be approaching dead on towards the vessel. You can see just a slight correction when we're moving this slowly will bring those together. Now, for those of you that do play Kerbal Space Program, I've always found that this is the one area where I get a load of questions. People find it extremely hard to do intercepts and also to organise a docking maneuver here. So just showing you the process that I would normally go through with the docking. First, I try to get them lined up pointing at each other. That means you don't have to keep trying to tilt them both together. And then you just try to keep your target marker and your prograde marker right on top of each other using the I, J, K, and L keys. After just a little practice, you'll be docking like this in no time. So we now have our vessel here back together. We're going to transfer our Kerbals back into the re-entry vehicle, leaving our wonderful little moon transfer vehicle there for another use at another time. Of course, it will need to be refueled before it can be used again, and that will quite possibly bring us to the next mission that we'll do, in where we need to actually create a very, very cheap refueling vessel that can probably be launched just with a single Falcon Heavy, and we want to be able to do that essentially without fairings, without everything, so I've been working on that as well. In the meantime, we are doing our last little retrograde burn here with our little Super Draco engines. We're just going to ditch that. This is going to be the only component of our vessel which has been lost, just that little engine section, and we're now going to re-enter just with a typical re-entry profile using our capsule here. Now, because our vessel here wasn't returning all the way from the moon, the entry velocity here is much, much lower than what the Apollo missions would have experienced. So again, the shielding doesn't need to be quite so hefty, meaning less mass and less risk as well. The lower the heat, the better. So Burberry and Valentina Kerman coming back to land down, splash in the ocean. We have those three massive Apollo-style chutes coming out there. Of course, this would all probably be a SpaceX Dragon if this was in real life, but nonetheless, we can splash down safely knowing that our Kerbals are safe, and we've got a reusable moon transfer vehicle ready to go on our next mission very, very cheaply. So I hope you enjoyed that video. Please do take a second and hit that like button. All of your support is just awesome. If you have any questions for me, please do whack them down in the comments below. If this video has earned your subscription, welcome to the channel. In the tile in the bottom left today, we have the mission where we sent our moon refueler up to the surface. In the top right is my latest video, and in the bottom right, a video that YouTube has just popped there because it thinks that you'll like it. So just click that, that's going to be amazing. Thank you as always for watching, and we'll see you all in the next video.